Good morning, everyone. I hope all of you are doing great. So, today we will start continuity. Before continuity, I hope all of you have solved a lot of questions of limits, right? Because we will need the knowledge of limits here and function also. So, continuity. We are talking about the continuity of a function, right? What does mean by the continuity of a function? A function which is continuous is called a continuous function, right? Continuous means something which does not have any break, right? So if the graph, we can make the graph of a function which does not have any break, this will be called a continuous function, right? And if the graph of the function have any break, it will be called discontinuous or maybe not continuous, right? Okay. So in our day-to-day language, this is the meaning of continuous function. For example, like this. This is the graph of a continuous function. Obviously, we can see it does not have any break, right? So this is a continuous function, right? Or we may say another graph, right? This is also a continuous function, okay? And what about this one? What about this one? Obviously, you can see we have to pick our pen here. It has a break, so it will not be continuous at x is equal to 3, right? Okay. So means anything which has a break is not continuous, and if it does not have any break, it is continuous function, right? So this is not continuous at x is equal to 3. Okay. So you understand? Okay, let's take another example. What about this one? Obviously, it also does not have any break, right? It is a continuous function, right? No, it is not a continuous function, because when we are talking about continuous function, first of all, this has to be a function, right? And if given graph is not the graph of a function, we will not talk about continuity, right? So you can see there is a vertical line which can intersect the graph at more than one point, right? So this is not the graph of a continuous function. This is not the graph of a function. No. So we will not talk about continuity, right? So just because this does not have any break, that doesn't mean it will be a continuous function graph. Okay. Okay. So, but whatever we have discussed till now, it is the graphical method, right? Okay, here you can write a normal day-to-day definition. Write it. If we can draw the graph of a function, in one go, without lifting the pen, then this function will be called continuous function. And this function will be called continuous function, right? But it is everything we have done till now is in graphical form, right or no? What about mathematical method? Because many times it will not be suitable to draw the graph, or we will not be able to, maybe function is a little bit difficult, okay? So mathematically, continuity at a point. So we are talking about continuity at a point. So a function fx is said to be continuous at x is equal to a if limit x tends to a fx is equal to f of a. This is our mathematical method. How to check the continuity? So we'll find the limit of the function at that point. We'll find the value of the function at that point. If both are equal, function will be said continuous at that point, right? If they are not equal, if limit does not exist, if function is not defined or any other reason, function will not be continuous at that point, right? But we can also write the same thing as f of a minus is equal to f of a plus is equal to f of a, right? LHL is equal to RHL is equal to value of the function, right? These two only refer that limit exists, right? Obviously this should be finite and unique. Finite and unique. Okay. So if this is the case, then function is continuous. Okay. So we can take an example. Like if we discuss the same type of function, this is the point 3. Obviously, by looking at it, you can tell, sir, it has a break, so it will be it will not be continuous, right? But we want to prove it mathematically. How we will tell mathematical reason, right? So if we can see what is f of a minus, means f of 3 minus, f of 3 minus is this value of the function at 3 minus is approximately 4, means 4, right? So f of 3 minus is equal to 4 here. What is 3 plus? F of 3 plus? F of 3 plus is 5, right? Approximate value. You all have this learned limits properly, right? So f of 3 plus is f of 3 plus is 5. Then we don't even need to check f of 3, because if f of 3 minus is not equal to f of 3 plus, limit does not exist. Limit does not exist, so this part will not exist. We will not talk about this. I don't know. So function is not continuous. What is the reason? Because LHL is not equal to RHL, right? It is the mathematical reason. Obviously, we can tell it by looking at the graph also. But reason is LHL is not equal to RHL, right? So that's why function is not continuous at x is equal to 3. We can see a little bit more explanation, maybe like this. This is continuous, right? That we want to check mathematically at 3. That the value of it is 4. So you can check what is f of 3 minus here. F of 3 minus is also approximately 4. What is f of 3 plus? That is also 4. Right or no? They will go like this. Approximately 4. And f of 3, that is also 4. Right? So that's why, because all 3 are equal, so that's why function is continuous at 3. Okay? Then that case, f3 minus is not equal to f3 plus. That's why it is not continuous. Right? And we may take another case also. Now here, what is f of 3 minus? F of 3 minus we can see like this. It is 4, right? What is f of 3 plus? It is also 4. I don't know. F of 3 plus is also 4. And what is f of 3? F of 3 is 5. Right? So here f3 minus is equal to f3 plus, means the limit of the function exists. Limit at x is equal to 3 is 4, but it is not equal to f of 3, because f of 3 is 5. So that's why not continuous at x is equal to 3. Right? Another case. that this is the case. Again same thing, just like it, but only difference is now this is open and we do not have the value of f of 3. I don't know, even f of 3 minus is 4, f of 3 plus is 4, but f of 3 is not defined, right? So how we will check our condition? So that's why function is not continuous. Why? Because f of a is not defined. F of 3 is not defined, not continuous. Get it? Okay. Now we'll take an example. Okay. Actually, in this chapter, continuity and differentiability, if your limits chapter is clear, if your limits are clear properly, then it will not be a difficult chapter. It will be very easy. Most of the times we will do just limits here also. Just we will check that LHL equal to RHL is equal to value of the function, right? So let's take an example. Given the function fx cos 6 to the power cot square x when x not equal to 0 and it is e to the power minus 1 by 2 when x is equal to 0. Okay. Check whether function is continuous at x is equal to 0 or not. Right? So we need to check if function is continuous or not at x is equal to 0. Okay. So what we need to check the continuity? Limit should be equal to value of the function. Okay. So first of value of the function is given, f of 0 is e to the power minus 1 by 2. So we just need to check the limit. If limit comes equal to this, function is continuous. If it is not, function is not continuous. Right? So find the limit. Limit x tends to 0 of x. Obviously, when x tends to 0, x is not exactly 0, right? So we'll use this definition of function. First of all, we will check if any indeterminate form is forming or not, right? So put 0 here, cos 0 is 1 and cot 0 is reciprocal of tan 0, right? Means infinity. So 1 to the power infinity form we are getting here, right? Solving that form is not a difficult task. Limit x tends to 0, e to the power, e to the power limit x tends to 0 cos 6 minus 1 into cot square x, right? Cos 6 minus 1 we have studied standard form 1 minus cos 6 by x square, right? And for cot square x we can convert it into 1 by tan square x, right? Here we are getting our 0 by 0 form, no? If we write cot square x as 1 by tan square x, it will be 0 by 0 form. We will use our standard limits for solving that. E to the power limit x tends to 0. Here take the minus common and we can write 1 minus cos 6 and divide it by x square. Tan square cot square we can write as 1 by tan square x, and in numerator, because we have put x square in denominator, so we also have to put x square here, right? Or multiply. This is the standard limit, this is also standard limit. Its value is 1, its value is 1 by 2. So answer is e to the power minus 1 by 2, which is equal to value of the function, right? So that's why function is continuous at x is equal to 0. Okay. So what we did, we just have find LHL, means LHL we did not need to find because function was defined in the same way for LHL and RHL also, right? Means if x is not equal to 0, doesn't matter it is in left or right. Okay, okay. Take another example. Given fx is equal to e to the power x minus 1 cube cosec ax divided by log 1 plus x square when x not equal to 0, and b when x is equal to 0. So this function is given that it is continuous, right? And then we have to prove AB is equal to 1. AB are unknowns, A are used here, B are used here, right? So we need to prove that AB is equal to 1. So again we will use the same thing. If it is continuous, that means its limit has to be equal to the value of the function, right? So find its limit. Limit x tends to 0 e to the power x minus 1 cube cosec ax divided by log 1 plus x square. Okay, so we will use our standard limit e to the power x minus 1 by x e to the power x minus 1 whole cube is there. Okay, we'll do that later. Log 1 plus x square, we can write it as log 1 plus x square, and cosec ax we can write as 1 by sine ax, right? So to make it standard, we need to multiply here by x cube. Now if we have multiplied by x cube in denominator, we also need to take it in numerator. Okay, log 1 plus x square is there, so if we put x square here, it will become a standard form, log 1 plus x by x. Sine ax, we have put x here, but here it is ax, so multiply by a and divide by a, right? So this is your standard form. Limit x tends to 0. Value of e to the power x minus 1 by x, its value will be 1, and this value is also 1. Value of this is also 1. So our answer is 1 by a, right? And this is equal to, because function is given continuous, so it is equal to f of 0, right? F of 0 is given as b. That means 1 by a is equal to b, or ab is equal to 1, right? Okay. So actually we just need to find the limits. That's the only thing. In continuity also, in differentiability also. Okay. So we can take some more examples, right? Okay, let's take one more example. Then we'll move further. Find the value of a and b, so that the function fx is equal to when x is between 0 and pi by 4, 2x cot x plus b, when x is between pi by 4 and pi by 2, a cos 2x minus b sin x, when x is greater than pi by 2, less than equal to pi. So this function, so that the function fx is continuous. So if this is given that this function is continuous, we need to find the value of a and b, right? Okay. So look, before pi by 4 and after pi by 4, definition of the function is changing, right? Here also, before pi by 2, after pi by 2. So we will use these 2 points where in piecewise function where is the breaking point, because there we may have doubt. If, okay, so here function is continuous, function is given continuous, so left hand limit at pi by 4 will be equal to right hand limit at pi by 4. I don't know. Left hand limit at pi by 2 will be equal to the right hand limit of pi by 2, also of the value, right? So first let's check at x is equal to pi by 4. Okay, we can find LHL and RHL by that lengthy way, but in this type of function we can, for finding the, because before in left of pi by 4 fx is defined by this definition, in right of pi by 4 fx is defined by this definition, right? So if we want to get the LHL, we can directly fill the pi by 4 in this, we will get our RHL. If we want to get RHL, we can directly fill pi by 4 in this, so we will get our RHL, right? When functions are given simple functions, so that way we can use. So at x is equal to pi by 4, f of pi by 4 minus is equal to f of pi by 4 plus. For pi by 4 minus, we can put the pi by 4 here in this. Sin pi by 4 is 1 by root 2. 1 by root 2 will get cancel out this, right? So this is your pi by 4 plus a. I don't know. Here put for RHL, put pi by 4 in this. Square pi by 4 is 1, right? So and x pi by 4 means 2 into pi by 4 plus b, right? So here pi by 4, here 2 pi by 4, so only 1 pi by 4 will remain here. A is equal to pi by 4 plus b. It is your equation 1. Now at x is equal to pi by 2. Again x is equal to pi by 2 also, f of pi by 2 minus will be equal to f of pi by 2 plus. Okay. Again we will replace value directly. What is f of pi by 2 minus? For before pi by 2, function is defined by this definition. After pi by 2, function is defined by this definition. So LHL will get from here, RHL will get from here, right? So f of pi by 2 minus, fill pi by 2 here, 2 into pi by 2. Code pi by 2 is 1 plus b is equal to, then for RHL put pi by 2 here, so a cos 2 into pi by 2 means cos pi is minus 1, right? Minus b sin pi by 2 is 1, so this is our equation. Pi plus b is equal to minus a minus b, right? So we will get from here pi is equal to minus a minus 2b, or we can send pi on this side. So this is our equation 2. From equation 1 we can write equation 1 like this, minus a minus b, plus a minus b is equal to pi by, what was there? Here it was pi by 4, right or not? Pi by 4. So add both of these values, minus, add. A will get cancel out, minus 2b minus b minus 3b is equal to pi plus pi by 4, 3 pi. 3 will get cancel out by 3, b is equal to minus pi by 4, right? For a we can get from here, a is equal to, means here pi by 4 plus b, b is minus pi by 4, so a will be 0, right? So that's how we can solve our functions. Okay. Now we will move further. So here we have just talked about the continuity at a point, right? But we will also talk about the what is continuous function. Continuous function is something which is continuous everywhere in its domain, right? So we need to talk about the continuity in some intervals or some a bigger interval, right? The interval, domain, closed or open intervals, right? So we will discuss that, but before that we need to discuss type of discontinuities. Discontinuities. Type of discontinuities. What is type of discontinuities? Means here we will get what is the reason for being discontinuous, right? So let's write about reason. Reason of discontinuity. So mainly there are 2-3 reasons for being a function discontinuous at some point. First one is limit does not exist. Limit extends to a fx does not exist. This is one reason, right? Second reason is limit exists, but it is not equal to the value of the function. That may be the case. Fx exists, but not equal to f of a, right? Third case is when limit fx exists but f of a does not exist, means function is not defined at a. Okay. Limit x tends to a fx exists but f is not defined. At a. So these may be some reasons, right? We don't need to write here limit exists or means function is not defined, right? F of a is not defined. That's it. Doesn't matter if limit exists or not. Okay. So these are the 3 main reasons. Now, depending on these reasons, we have given different names to the reason of discontinuity. We have separated them in different cases. So discontinuity can be of 2 types. Mainly, first one is removable discontinuity. Why removable discontinuity? Because this type of discontinuity can be removed, right? Same referred by name. Non-removable. Right? These are removable, these are non-removable. So removable discontinuity will exist when limit of the function exists. Limit x tends to a fx exists. Right? And here limit will not exist. Does not exist. Right? Now removable discontinuity is also in itself of 2 types. First one is when limit exists but function is not defined at a, right? Fx, fa, f of a is not defined. Right? Here, in second case, limit exists obviously, first of all. Then function is also defined, but limit and function value is not equal, right? So limit x tends to a fx not equal to f of a. right? This type of discontinuity is called missing point. Missing point. For example, for this can be like we have discussed earlier also on this. Here limit f3 exists, but f of 3 is not defined, so it looks like a point is missing, right? And why we call it removable? Because if we can define a function at 3 equal to the value of the limit, it will become continuous, right? For example of this is also something like that also. Limit is defined, but value of the function is something else. They are not equal, right? So it looks like point is isolated, so that's why we call it isolated point discontinuity. Isolated point discontinuity, right? Now non-removable discontinuity are of 3 types. Non-removable. First one is finite type. Finite type. Finite type means when LHL and RHL both are finite, then it will be called finite type. LHL and RHL both exist and finite. For example of this, something like this. LHL is 4 here, RHL is 5, so both exist and both are finite, right? So this is finite type discontinuity, okay? We also call it jump discontinuity. Because it looks like we are taking a jump. When we are going from left, we are taking a jump from here to there, right? This is called jump discontinuity also. And jump of discontinuity is equal to, means how much jump we have taken, is equal to RHL minus LHL, and we will take the mod of it, right? Second one is infinite type. Infinite type. So infinite type means any one of LHL or RHL or maybe both is infinite. At least one of LHL and RHL are infinite, right? So this may be the case with, for example, 1 by x. This is infinite type discontinuous at x is equal to 0. LHL is going to minus infinity, RHL is going to plus infinity. Not necessary that both should be infinite, any one also will be enough. And last is isolatory. Isolatory type. Isolatory type means limit will isolate. Isolate between two finite quantities, finite values. For example, sine 1 by x at x is equal to 0. So if you take the limit of sine 1 by x at x equal to 0, when you will take limit x tends to 0, 1 by 0 will go to infinity. and value of sine infinity can be anything between -1 to 1. So you will not able to decide it will be -1 1 or something in between, right? So it will isolate between -1 to 1. Okay, so that's why it is isolatory type of discontinuity. So these are the different types of discontinuity. We can also write their examples if we want to write a particular functions. For example, for this missing point, we can write fx is equal to x square minus 4 by x minus 2. At 2 it is not defined, but you can check its limit will adjust. Okay, you can check it yourself. We can write at x is equal to 2. This one we can also take same thing. Here just we need to add one more thing because fa was defined here. Here f is not defined at 2. We need to make it defined. X square minus 4 by x minus 2 when x is not equal to 2. And we just need to take a value of the function which is not equal to the limit. And it will become isolated. 5. Right? Jump discontinuity. Jump discontinuity we can take anything like fx is equal to x square. Oh, we will also write at x is equal to 2, right? X square when x is between 0 to 2, right? And 3x when x is 2 to 4. So at x is equal to 2, it will have jump discontinuity. As you can see, at 2 LHL will be 2 square means 4. RHL will be 3 into 2 6. So LHL and RHL are not equal but both are finite, right? Infinite type discontinuity. For this, we can take an example, infinite type. Fx is equal to 1 by x when x is less than 0. And it is x plus 1. It is x plus 1 when x is greater than equal to 0. Right? So this is an example. You can check its LHL will be infinite, minus infinity. But RHL means we have given first example 1 by x, LHL and RHL both were infinite. But here only LHL is infinite, right? 1 is enough. Even if 1 is infinite, that will be infinite type discontinuity. Okay? Okay. So note it down. So I will not give you, I will not, whenever we will solve question, then in the same questions we can check if which type of discontinuity is there. We will not take their example separately, right? We don't need to. Okay, so for now we have just discussed our type of discontinuity. Okay, now we will discuss some important fact when a function is said to be continuous. When what are normally continuous function with which we deal in day-to-day life, right? So write a note. A function is said to be continuous function if it is continuous at every point of its domain. Means to be a continuous function, that function has to be continuous only in its domain, at every point of its domain, right? For example, like if we take 10x, right? 10x, is it a continuous function? Normally, like we have checked, we have taken the first definition that whenever graph has any break, it will not be a continuous function, right? But check for the 10x. So we know this is the graph of 10x. This is pi by 2, right? And it has break. It breaks here. Graph of 10x break at pi by 2. I don't know. You all have seen. But the thing is, pi by 2 is not in the domain of 10x. Right or not? Pi by 2 is not in the domain of 10x. That's why it doesn't matter. It will not have effect at the continuity of 10x. Okay? Minus pi by 2 to pi by 2 is in domain of 10x. It is continuous everywhere, you can see. From pi by 2 to 3 pi by 2, it is in domain of 10x. It is continuous everywhere. It is not, means it is graph of the function is having break only at odd multiples of pi by 2. Right or no? But we know that odd multiples of pi by 2 are not in the domain of 10x. Right? So 10x will be said a continuous function. Got it? 10x is a continuous function. Does it have any point of discontinuity? Yes. Even if it is a continuous function, it have some point of discontinuity. Same thing, pi by 2. X is equal to pi by 2, 3 by 2, 5 pi by 2. These will be the point of discontinuity for 10x. So, if we do not have any point of discontinuity in domain, because they are outside the domain, right? So if we do not have any point of discontinuity in domain of the function will be said continuous function. And a continuous function also can have some point of discontinuity, but outside the domain, outside its domain, right? Okay. Like point of discontinuity of of 10x are odd multiple of pi by 2. Right or no? Okay. So means continuity. In other words, we say that continuity is a concept of domain. We will check only in domain. At outside point, it may be discontinuous. That doesn't matter. Okay. Okay. So some important facts. This you may consider as note 1, and this one is second one.